A very good afternoon to all of you. Today we are going to do a numerical on photoelectric effect. Okay. The first numerical given to us to solve is a very easy problem. So the numerical what is being to be solved is an IIT JEE level, mains level problem. The photoelectric effect numerical. Basically, what is a photoelectric effect? Then we'll write the question. There is a cathode ray tube and there is an opening here. There is one electrode here and there is one electrode here. On this electrode, we put a photosensitive metal like sodium, potassium, rubidium, cesium. These are 1A group elements. They have one electron in the outermost shell. When light of sufficiently large frequency falls onto this photosensitive metal, what basically happens is one electron is scooped out, or it just gets the ionization, IP1, we call it in chemistry IP1. The first ionization potential is satisfied, so one electron will come out of this photosensitive metal and will start traveling towards the other electron. When these two electrons are connected by a simple galvanometer, it will register a deflection, which clearly indicates that there is a photocurrent passing through this circuit and the circuit is closed. Now, what is given to us in the numerical to be done is this. They have given the same situation. Along with this, what they are doing is, if you are applying a battery. Now, in general case, without considering this numerical, in general case, you have to apply a negative terminal of the battery to this photosensitive metal and a positive terminal of the battery to the other electrode. So that makes the other electrode positively charged or positive potential, and this, since it is negatively charged terminal of the battery which is connected to the potassium, sodium, whatever photometal, the electron coming out with some amount of incident energy due to the photon impending some energy to this photoelectron. This negative charge will reflect or repel this electron and will accelerate it towards the positive terminal. So that is why the Einstein's photoelectric equation is given as incident energy h nu is equal to h nu naught, which is the work function, or the minimum amount of energy. The work function is nothing but the minimum amount of energy or the threshold energy with which the electron will come out without any battery. If there is no battery, in the earlier case, when there is only galvanometer, the electron will just come out with this energy. Now, since there is a battery to accelerate this electron, it will get a kinetic energy to accelerate towards the positive terminal. Yes, this is called as Einstein's photoelectric equation. I am writing it down. Einstein photoelectric equation. Now, how do you get this kinetic energy? That is the problem. Now, how do you get the value of kinetic energy? First, to get the kinetic energy value, what you have to do is reverse these terminals of the battery, applied potential difference, you have to reverse it. That means you put positive terminal here and negative terminal here. Now, what happens? This is the variable battery. This is the variable DC battery. The earlier case, we didn't have this arrow. Now, we are having an arrow because it's a variable DC battery. Now, when there is a variable DC battery and you keep on increasing, what happens is, this negative terminal goes to this P terminal. So this becomes negatively charged, negative potential, and this gets a positive potential. Now the electron, with whatever energy it has come out, the fastest moving electron or the highest energetic electron will also try to come out of the photometal but cannot accelerate up till reaching this P terminal. Why? Because you are applying a repulsive potential difference, so the fastest moving electron also half mv square, Vmax square of the electron also will be stopped, will be momentarily stopped, and then there will be no electricity registered in the galvanometer or the ammeter. We can put an ammeter or a galvanometer to find out if there is any deflection. Galvanometer is enough. To find out how much current is coming out, ammeter is also required. So any of these two meters will register where there is a reflection or not. There will not be any deflection in the galvanometer or ammeter, and the meter shows null reading. Why? Because there is the fastest moving electron is also stopped by applying this negative potential difference. Now what is negative potential difference? That is minus Vs. This minus Vs which I have applied is called as the stopping potential. Stopping potential, because it stops the fastest moving electron. When you stop an electron, the stopping potential is converted into kinetic energy. How does that happen? The kinetic energy is basically half mv square. This is not new, this is v max square, which is equal to the work done on the fastest moving electron to stop it. What is work done on a charge? It is basically qv. What is q here? Minus e into what is v? Vs. So this is the meaning of kinetic energy. This is how we can get the kinetic energy of fastest moving electron. So minus EVS. Now kinetic energy having been a square of velocity, even though we put negative here, we just want the modulus part only. So what we write in numericals, what we are going to write is half V max square is basically the modulus of EVS. So that turns out to be simply plus EVS. Okay. So now coming back to the numerical which we have to do. Having understood this basic concept, now we can do the numerical. We can proceed to do the numerical. In the numerical given, they are asking you to find out the amount of incident. They are asking you to find out what is the amount of incident energy of photon. If they are asking what is the incident photon energy of photon if the photometal has a work function W naught, which is sometimes written as phi naught, is equals to 3.5 electron volts, and they are saying in the question, and the emitted electrons can be stopped. The emitted electrons can be stopped. So they are saying stop means stopping potential Vs is given to us with applying a minus 1.2 volt. So this converts into kinetic energy maximum. So what is the incident energy of photon? What is incident energy of photon? Is nothing but h nu, which is equal to h nu naught plus half m v max square. But we know already the h nu naught, which is nothing but w naught. Or we can also write this in some textbooks, it is phi naught in DC Pandey books like that. So this has been given to us as 3.5 electron volts. What about half mv square? Half mv max square, just now I told you from theory, it is nothing but the modulus of minus EVS. So that comes out to be minus E into 1.2, which is given there, volt. So that after modulus taken out, it converts as 1.2 electron volts. So that is your Ke max or kinetic energy. So what would be the incident energy of photon? So they have given us 3.5 electron volt, which is the work function of the photosensitive material or metal, which may be sodium, potassium, rubidium, plus the kinetic energy, which is nothing but the stopping potential into the electric charge. So this comes out to be 4.7 electron volts, which is the energy of incident light or incident photon. So in the options given to us, option A, B, C, D like that, we have 4 options. What is the first option is A option is the correct answer, because in the option A itself the incident energy of photon is given as, the A option itself luckily they are given to us as 4.7 electron volts, and in the B option they are given to confuse us. They have actually given the B option because generally by seeing this negative part, what actually happens is students tend to subtract it. So that is why they have given this B option as 2.3 electron volt, because if you subtract these two you get this, but that is the wrong answer. This is the correct option. And of course there is a C option and D option which are not so correct anyway, because the first option is correct, right? Thank you very much. I think that answers your question. Thank you very much.